No. Pretty easy. Who are we missing today? I forgot to take minutes. Who? All right. Very good. Thank you. All right. No questions about your homework then? It was pretty easy. All right. Y'all ready for the number E? Yes, because we will do this on the E is a number we pull from the calculator. All right. So let's talk about E. Let's talk about the number. So E is actually an irrational number. What does irrational mean? Say it again. Give me an example of a common irrational number that you know. Pi is irrational. Okay. It doesn't repeat. There's no pattern to the numbers that follow the decimal. It goes on forever and ever. It never stops or repeats. Okay. So you can't express it as a fraction is what it is. So we call it irrational. When we talk about rational numbers, those can be expressed as a fraction, and they do have a pattern or they terminate. So the approximate value. So I want you to take out your calculator and I want you to pull up the E there. I think it's second ln on your calculator, and you'll do to the first power. And tell me approximately what you get here. It's the log. You see the ln button? Go second ln, and I think that's your E. Is that it? And then do a 1 for the exponent. So what do you get? 2.71. And I'll just stop there. I'll stop 3 decimal places out. Okay? But notice how it keeps going on and on forever, just like pi. Okay? Irrational. We're not going to get into exactly what it is and how we calculate it because we're a little short on time. It's actually a limit. We'll talk about it more in pre-cal than we will in here. So yay for next year when we talk about limits. Or not. It's okay. All right. Thank you, Jaquita. I appreciate that. Huh? As of right now. Awkward silence now. Everybody's like, exponential functions with base E are called I call them exponential functions. Base of E. Remember how I said if you don't have a base written of whatever it is, what's the base that's there? 10. Well, we can also have a base of E. And if we have a base of E, this is what we call a natural log. Natural log. And we can rewrite this as ln of x, and that's the same thing as a base of E. Okay, so logarithmic functions with base E are called natural logs. And it can be abbreviated this way. Okay, so notice that ln button I was telling you on your calculator, go second ln. That's that natural log, okay, which is just the same thing as a log with a base of E. Everybody okay? All right. Let's convert between some forms, and then we'll work some more. This is not really hard today. It's just plugging this E in and learning to recognize E just like you do pi, and you do all the same operations with it and all the same things here. And then we'll, tomorrow we'll get to the application of it. We'll do some growth and decay and that kind of stuff with E. So let's look at number 1. We have E to the x equals 24. And it says to rewrite this in logarithmic form. So what does this look like in logarithmic form? That's exactly right. ln, which is the same thing as log base E, right? of 24 equals x. Instead of writing log base e, we just write ln. Okay. We still read it log. We don't really read it natural log. If you want to say natural log, you can. We still usually just say log 24. But written down, that's natural log. How about number 2? All right, say it again. Natural log of easy. It's what we've been doing. It's just there's an e there instead. How about number 3? We have e. This time we've got this polynomial in the exponent, but I'm still going to do it the same way. What's it look like? Notice I'm not solving just yet. Right now I'm just changing forms. Remember I told you when we started this, changing forms was going to be easier. Everybody okay? Yes, good, thank you. On yours? You don't understand what? All right, so shift. You gotta have an exponent on it because it's saying e raised with some power. Oh, you don't understand what? Somebody said they didn't understand what? Oh, okay. Let's go the other way with it. Look at number 4. These should be quick for you. So I'm sorry if I'm boring you going so slow. I have natural log of x equals 58. Change that to exponential form. What's it look like? Y'all are so smart. Is anybody struggling? What's number 5 look like? E to the x equals 6. How about number 6? E to the 32nd. That's right. That's right. Perfect. Everybody good there? Don't need to spend any more time on that. Again, this is the same thing you've been doing. It's just with an e and with a natural log. Maybe we should have done the other lesson today too. This is so easy. All right, let's condense then with our natural log. Same properties still apply. It's still a log. It's just a log base e. So if I have the natural log of 3 plus the natural log of 16, how does that condense? You multiply because I'm adding. So what does it become? That's exactly right. Is this boring, y'all, because it's so easy? That's good. Y'all have breezed through most every lesson here, so I hope that means y'all are going to do really, really well on the test. How about number 8? I have the natural log of 63 minus 2 times the natural log of 3, and I want to condense. What do I do first? That's everybody's saying the 2, the exponent. Y'all are exactly right. So I have the natural log of 63 minus the natural log of 8. Now what do? I'm subtracting here. I did 2 to the 3rd. I'm sorry. And there you go. Y'all keep me straight. Nope. All right, y'all try number 9. Y'all try number 9, see what happens. What'd you do first? Those exponents. What is 64 to the 1/3? 4, because 4 times 4 times 4. And this becomes Because I'm adding, all I have to do is combine them with multiplication. So this becomes the log of, that's exactly right. I'm done. Everybody okay? Let's do some expanding then. Good, number 10. The natural log of 5x. If I expand that out, what does it look like? That's exactly right. I feel like this is way too easy for y'all. We'll get to solving in just a minute. But it's still the same thing you've already done. It's just natural log. All right, so now I have this fraction with this exponent on the outside, and I can do this a couple of ways as I expand, but I want to make sure as I expand there are no exponents still there. So what do I do first? Or what's one thing you could do first? I could distribute that. I would probably do the same. I would say this is the log of a to the 6th over b to the 2nd. What now? Split them up. A to the 6th, split them up how? What do I split them up with? There you go. Log of b squared. Now what? Now I'm completely expanded, right? How about 12? Y'all try 12. So it's a little bit harder because there's a radical there. Remember, radicals can always be written as what? Fraction exponents. That's exactly right. What'd you do first? What does it become? Cubed root is the same thing as what exponent? Somebody said it. Right? I would distribute this through just like you did the last one. Thirds, 1/3. Now what? So I'm going to split it up because I'm multiplying. Let your exponents be the last thing you do. And now they come around to the front. So 2/3 natural log of m plus 1/3 log n. Okay? Yes. Now what you could have done if you wanted to, when you got to this point, you could have done 1/3 the log of m squared n, right? But when you split that up, this 1/3 has to stay going to everything. So it'd be the log of m squared plus the log of n. It has the point is that it has to stay in front of the whole thing instead of just to one. So that's where it gets a little confusing here. Like, all right, everybody good? Ready to solve? You need a break in between? Are y'all okay? Are you with me? Are you not? Some of you just look comatose. Y'all are just going tired. All right, well, let's solve some, and then I'll set you loose. Remember the solving, we're still not going to check for extraneous solutions. The solving is going to be the exact same thing we did before. We're going to look to see if we can condense down to just one log or if we can get just a log on either side and drop the log. Okay, so same scenarios. I'm just dealing with natural logs instead of logs of other bases now. So look at number 13. I have the log of 4x minus 27 equals the log of 15 minus 2x. Tell me what I do. So yes, because they're separated and there's just the ln's on both sides, I can drop those ln's there and just have 4x minus 27 equals 15 minus 2x. Now I do want to say that if I'd had like plus 5 here, that wouldn't work. I'd need to get both logs on the same side and condense. But because it's just the log of something and the log of something, I can drop those that way. Now this is an easy solve. What do you do? Well, that's fine. You can do that. If you plus 27, I need to add the 2. That's right. So I'd end up with 6x equals 42. So x is 7. Easy peasy. It's what we've been doing. It's exactly what we've been doing. All right, I'm going to skip those. I'm going to skip down to 19 because you're exactly right. This is exactly what we've been doing. Actually to 20. And let me show you how it's a little bit different here, but still it's all the same thing. In fact, we might do 22 because it's the hardest. That'll give you plenty of practice. We have 2e to the c minus 9 plus 3 equals 87. So I'm solving an exponential equation. I know it's an exponential equation because the variable is in the exponent, right? And so my goal my first step as I solve an exponential equation is to isolate the exponential piece, okay? So if you get confused on what the exponential piece is, sometimes it'll help to kind of circle it. It's only the base with the exponent, so nothing else. So this is what we're trying to get all by itself. That means I even need to get rid of the 2 in front, okay? So what do I do first here? Subtract 3. So I have 2e to the c minus 9 equals 84. What can I do now? Divide the 2 on both sides. So I have e 42. Now what do you do? Once you've got the exponential piece isolated, what do you do? So it's log, the base is e, so I can do natural log of 42. This is on your calculator. Literally, you hit ln 42, and you're going to get a decimal. What do you get? That's fine, yeah. 2 to 3 places out. Now all I have left to do is what? Add the 9. Anybody struggling with that? Is everybody okay? Yes. That's it. Now, I'm happy to work any more with you if you need them, but I don't want to stand up here and bore you if you can knock these out and be done. Yes, one more, Stacy. How about 20? E to the y plus 3 minus 6 equals 24. So again, I'm isolating the exponential piece, which is this. So that's exactly right. Plus 6 on both sides to try to get it by itself here. So I have e to the y plus 3 equals 30. Now what? When you get the exponential piece by itself, change the form. Okay? So it's going to be log base what? What's the base? E. Anytime I have log base E, that's the same thing as ln. So that's log base E of 30 equals y plus 3. So I'm still doing this changing between those two forms. Log 30 is a calculator problem. What do you get? What is it? That. And now what? Subtract the 3. That make sense? Y'all ready for me to stop so you can do your stuff? I sure could. So 14 goes back to a log equation. So I have 2 log k equals log of 2k plus 15. So it looks like I have 2 logs, but I'm not quite ready to drop the logs because there's something hooked to the first log, right? There's this 2 in front. So I'm going to condense this down by bringing it around. So I'd have the log of k squared equals the log of 2k plus 15. Now I can drop the logs off because it's just log equals log and there's nothing else there. So here k squared equals 2k plus 15, and it looks like I have myself a what? A quadratic. So if I have a quadratic, I need to make it equal 0. Try to do what? Factor. Y'all are so smart. You will have to FOIL that n plus 4 out. Or actually, what you can do, I'll show you that one. I'll show you that one because you can do something else with that. If I factor this as a shortcut because there's a 1 in front, k minus 5, k plus 3. You said 16. So on 16, I have 2 log n plus 4. So same concept here as far as condensing before I start. So this is going to be the log of m plus 4 squared equals the log of 4. I can drop those off, m plus 4 squared equals 4. And what you can do now, instead of actually FOILing that out, you can just solve from here. You can square root both sides and then subtract 4. Because this is, the variable's only written one time, so I can stab map my way back out of it. So I can do this. You'll have 2 solutions, because that's a plus or minus 2, and then you'll just subtract 4. Yes, if you FOIL it, you should get m squared plus 8m plus 16 equals 4. So m squared plus 8m plus 12. 6 and 2. You get negative 6 and negative 2 here. 2 minus 4 would be negative 2. And then negative 2 minus 4 would be negative 6. So you get the same 2 answers. You can do it either way. Yep.